Hello, my name is Puren Thapa. I am a student of the University 6th semester BSc Physics Honors, and today I will be showing you some codes of 6th semester statistical mechanics labs that will be helpful for your examination for the university mainly because I am following the university syllabus. So let's get right into it. So this is the Scilab console, and if you have studied for 6 semesters, you should know this by until now. So we will be doing the first code in our syllabus. This is the code for the macro state probability graph. So firstly, we have to take an input n. Macrostate is simply describes the macrostate properties of the uh, macro properties of the system. So first we will take input, enter the number of times we are taking the example of simply the here we're taking the example of simply the case of coin tossing, which is a two-level system is mainly to speak. So let's get into it. So we have to first see how many coins to be tossed. So enter the number of coins to be tossed. So now we have uh, a variable n which stores a given number given by the subject of or the inputter or simply the user. So now we will display the number of macrostates and the macrostate firstly. So if we display firstly we will display these are simple the number of the total 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 the total number of macrostates. I will try to write fast, and so I will do mistakes also, so you can correct it. So now we will display, what will we display? Simply it will be n plus 1. So the number we have given, the number given by the inputter, we can display n plus 1. You can also write this here also. So simply you can run it and see if it works. This is very simple code. So like we have put 3 and our answer will come 4. These are number of macro states, and I can do it like this. I can just firstly I should do it like this, so we have easier time here. So like this. Now we will display the number of macro states. Display uh, the we can simply copy paste. You should never be afraid to copy paste because in examination we will have you can write it down. It will be practice for your typing, but I prefer to copy paste some of them. Number of macro states. My type is still improving. So now we have number of macro state. Now how will we calculate number of macro state? We can give a variable m and we will give its value 1 divided by 2 to the power n. This is simply the formula you have to learn, and we can simply display m, display m. Also the total number of macro states, display the total number of micro states will be. This is a very simple code, so I will run through it very fast. You all should be able to do it. So this will simply be display to the power n, simple to the power n. And now we will form a for loop for calculating the different type number, the different macro state probability. So simply we will start a for loop from I is equal to 1 to n plus 1 because they are the number of macro state, n plus 1, and we will simply put a function pi which would be equal to factorial f factorial n. You should remember the formula by now because it's a very familiar formula. N factorial upon factorial n minus factorial I minus 1. We are doing I minus 1 because we have to include the zeroth one also. I mean meaning nc01 also है ना. this computer will start from 1. So for putting it to 0, we have to put I minus 1. Simply, it's very easy if you think about it a little. Matlab, I minus 1 will give us 0 factorial. So 0 factorial is 1, and we will have n factorial upon 0 factorial into n factorial. You will see factorial factorial n minus, अब now n minus I plus I minus 1, so minus I plus 1, simply minus I plus 1, and we will also have to multiply this term with 2 to the power n of simply, है ना, so we have to simply multiply with this term with the 2 to the power n. देखो, this is the macrostate probability, and we have to simply multiply by 2 to the power n, and here we have it, and we will close the bracket. This bracket is being closed, you can see this like this bracket is closed here, this bracket is being closed here, and this is being closed here, and we have to we can also put one bracket here and one bracket here to show that these are different terms. And now I suppose we have a functional code, we can further do it like this, and this, and like this, to further differentiate the terms. So this ends here, so this term, this bracket terms here, this bracket terms here, this bracket terminates here, and this bracket. So all the brackets are complete by now. So we will put x is equal to 0 to 1, that is number of heads, and we will simply plot x comma p. It's that easy, and you can put x label as number of heads or simply macro states, and you can put y label as probability of macro state, probability of macro states, and we can simply run this program and see if there are any number of head times 4. Hey, let's see, take 100 simply. In your code you would you can see the graph is coming out to be correct. So we are on to our next code. So now again write clear CLC CLF are like the basics of CLF. So matlab this must you will have no clear CLC and CLF. CLC is clear screen, and this is for clearing console, and I suppose CLC and CLF, one is for clearing the uh, the the menus, and one is for clearing the graphical window, I suppose. CLF is for, I suppose, clearing the graphical window. And now we will save it, and we will write a name for it, video code 2. And now we will come to our second code. Now this code is like a little bit complex, but it's not that complex because it is about Planck religions and Wayne's displacement law, है ना, Wayne's law for black body radiation. So simply we'll start by putting constant h is equal to, we'll say start by putting constant h, we can take the constant from, let's write it down only, 6.626 into 10 to the power minus 34. This is the value of Planck's constant. Simply we need this, and we cannot write directly, so we have to write minus 34. Now it's correct. You can either write it like this, or you can put 6.326 e minus 34. And now you put the value of c also, because the formula is c also, 3 into 10 to the power 8. Define value of k also here, only 1 point. These are the values that will come in handy later on, because they are being used into 10 to the minus 23, and you should learn them. It will be much easier for you. It will one, or else it will be a hassle for you later on. So now first we will plot the Planck's radiation law for 3 different temperatures. So let's form a matrix of temperature. To form a matrix like this, we can form matrix of temperature, we can form like this, or we can use a linspace command. to form three commands. So let's simply do the most easiest one like this. 500, we will take three temperatures: 100, 500 and 1000. These are the three temperature, and this will be in Kelvin. So now what we have to do is, first we have write down T. Now we have between need is, we need a x-axis. So in x-axis we have lambda. Lambda is wavelength. So for lambda we will write we will write what I have written. For lambda we can write L for lambda. So L is equal to, we can give the value as lin space. This is the command I was talking about, lin space. We can generate command points like this: 0.1 micrometer. So for writing micrometer we write 10 to power minus 6. So this is like 0.6 micrometer. For 0.1 micrometer, so 30 micrometer, 30 into 10 to power minus 6. This is 0.1 to 30 micrometer with number of points. Let's say we take 1000 points. 100 points would be enough, I suppose. So now let us make the take the length of T and L to form to put in a loop. So we can directly write them in the loop also. So let us form a loop. For loop, for first we have a loop for T. For T we will have phi is equal to 1 to length of T, length. Length of this is for Mm, the for loop for the temperature changing, and this is for loop for use a different variable for loop for changing the wavelength. So simply we will write like this, and simply length, 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 and we will write L. So this simply we have simply one end, so we will put two ends, and now we simply write the formula for Planck's addition law. We I can show you the formula like this. Insert, draw. So the Planck's radiation formula is like Planck's radiation law: 8 pi hc upon lambda ki power 4, lambda ki power 5, 1 upon e ki power hc upon lambda kt minus 1. This is the Planck's radiation formula, and for uh, releasings we have 8 pi kt upon lambda ki power 4 and 8 by 80 upon lambda ki power 4. And for Wayne displacement, Wayne distribution law, we have 8 by h. Simply remove this one, lambda ki power 5 e ki power minus h upon kt. Simply remove the one. It's that easy. So this is the formula. Now we can simply write the Planck's addition formula here. So we can write a function like f1 fi comma j, because it will use both the variables. Fi comma j is equal to, let us take for the temperature, let us take firstly 8 into 8 into 8 into pi. Percentage pi is written as percentage 8 into percentage pi into h into c, which we have already defined. We can put them in a bracket, and this has to be multiplied by with divided by lambda, which is L. We have to divided by L, and it's listen to it, listen, they take the note of this. We have to write j here because j is varying with lambda, and we have to write to the power 5, lambda to the power 5, and close the bracket, and again multiply, and again use this, and divide 1 divided by, again use a bracket and close two brackets. And now we will write the formula e ki power hc exponential, and again to this exponential h into c, h 8 by hc upon lambda की power 5 e की power hc upon lambda kt, e की power hc divided by, now again we will write this lambda kt, lambda lj into k into t, and for t we will write like this ti. And let us see the formula is correct or not. So this bracket is coming off at this, and this bracket is coming off at so this bracket should be coming off at, sorry, first ti, then this bracket is for L complete, and this bracket it should be for this complete. This is also correct. and this bracket is for complete this, and this bracket is complete. So we have simply put -1 here and we have a complete formula. If we can use it, we simply have to write the formula, and now we will have values of three values of this, so we can simply plot and we can see that 8 pi hc upon into lambda k. So we would have like many values, so we have to plot with l comma, and we have to plot, so we will like write this f. First we will write like 1 comma 1 comma double dot, so and like f 1 comma 2 comma double dot. We had three temperatures, so again write f 3 comma double dot. So this chooses the entire column, the column changes in the entire row, mainly the third row, and this is like choosing the entire row, and we can write x label and y label. X label as lambda in micrometers, lambda in micrometers, and we can simply mm, sorry insert, and we can put y label as simply the new, or the energy density, we can say. We can see new lambda. So this much is enough, I suppose, new lambda, and we will draw a bracket here also. So now we can see if the value is correct. The syntax array is coming, so we can write plot 2D, because I suppose in plot it is not supporting, and again it is coming out to be error, so we can just simply do dash dash, so that we can transpose the matrix. And if again it's coming, then syntax expected end of the line expecting. So I have done this. We can simply put this, and we have to put square bracket here. And now let's see, the graph is coming out to be a little wrong, too much wrong. I am also a student, so let's see what we have done. So first we can even I don't suppose we have to replot, so let's see what the graph is coming like. So the graph is coming quite unwell, so what we can do here, so the graph should be coming like the ideal graph, so we must have done something wrong. So first we will display the value of f. So we have three column matrix, so we can simply, if we remove this, let's see if some error is coming. Input out plot to the wrong size the input argument, so we were doing correct, we are doing it correct. Now we have just to see the formula, and we can simply copy the formula from somewhere else, because we don't have much time. So let's see where I can go to. So this is the formula, I suppose. No, bit where I was and here I was, so let's simply copy the formula, and this is my code too. I have already made this code, so we can simply just copy the formula we have written. So this is the formula we have to write, so I will simply copy and paste it, uh, control C and control V, so there's no error in the formula. At least we know that there are no errors in the formula, so we can simply uh, वो क्या बोलते हैं, comment it out, and simply from I comma j and equal to control V, and now we have simply a formula. And now let's see the invalid index at line 12, and the graph is also not coming. So let's see what f I comma g percentage pi h into c lambda I into to the power 5 lambda I to the power 5, it should be j lambda j to the power 5 exponential h into c lambda j and ti. Now it should be correct, I suppose, from what I have seen. So you can see that the graph is coming out to be correct. We can furthermore correct it by using different temperature to work up more correct temperature like 400, 500 or 1000. Now let's see what we have. Still also the graph is a little too much staggered. So let us see what temperature I have taken in this. So we have taken from 500. So 500 above it's coming out to be correct. So I will write 500, comma 600, comma 700, comma 800, comma 900. So I suppose this must be correct. This must be the correct graph. So you can see the graph is coming out to be correct. Now we can simply use legend here to see which graph is of which. So using legend and put legend t equal to, and put it with t equal to plus string, and use plus string, and use the temperature term here. Use the temperature term here, and capital, not capital T, is small t. Why am I writing capital? My caps lock is not on. Anything is not on. Why it's writing capital T? Sorry. And now we will have R Kelvin. This is simply a code. So you must memorize it. I also memorized it. Simply matlab, this string is used for writing the text temperature here. And now we'll see it will give the exact temperature with the exact temperature. T is equal to V. I didn't write equal to. So if I write equal to here, so now you can again see this gives like this, and this is a correct graph. So now this is the correct graph. So now we have, so in my examination I have taken 4 or 3 cups, so it should be coming like 4 or 3 cups. So I must have written something wrong. So if we take more number of points like 1000, so let's take 1000 and see what's save and execute and see what's coming. Still the temperature not coming, but the graph shape is correct. You can see the change in the shape position or shifting. There is a position shift. So we have the graphs for 700, 600 and 500k only. Why it's not plotting for 900 and 1000? I also don't know. Let's see what's the problem. Length of t, and it's coming some problem, but you understand the idea by now what it's doing. And now let's do the program for uh, mm, now let's do the program for the second part of this code. So we can do control D to comment it out all, and now we will do the second part of the program where we have to compare all the three formulas. So simply we have to take a temperature, simple as we take a single temperature. You can take a single temperature T, है ना? So we take a single temperature, we can take a single temperature T. Let me see how I've done it. So you can take a single temperature T, and you can input it, but I will give it so I will give it myself. So let us take 600 Kelvin. Now this is a sorry 600. Which we will not write Kelvin because he doesn't, but the computer doesn't know what is Kelvin or not, whether if we don't tell it what is K. So now we have taken this, and again we have to write L space because uh, we have to have something on the axis, to be plotted. So we will write like this, and now simply by using simply a for loop for length only, for loop for I is equal to 1 to length of len 1 to sorry 1 to length of length length of L. Now this will be enough for this because we are not changing the simply the temperature here. Simply one variable is getting changed. So now we will write the three formulas and simply plot the graphs, and we will have our answer. So I will again copy the formulas from this formulas I have written already here. You can see this is the part where I have written the formula, so I can simply copy and paste it. So either here also I have used I loop, and here also I use I loop. So let's go there and simply control V it, and now we have the complete code, I suppose, if we don't have any errors. So now we have PI, BI, and we have the PI, BI, and WI curve for different for at temperature 600 Kelvin, है ना? So now let's plot it. So first I will do it like this, and now we have to plot it. So we can simply use plot 2D plot. Sorry, my caps lock is on again. Plot use plot 2D for plotting many graphs like at once. So we will use length as L, matlab lambda as the x-axis, and yeah, and put pi p comma w comma p comma r comma w here. R comma, you can write in any order, it doesn't matter, but for simplicity I am writing it. And we can give them numbering like -1. This is for the symbols. You will see what symbols I am talking about. The symbols will form the graph now. So we have done a little mistake. This should be in square bracket, and the plot to the one should be in the close bracket. So there, here it is, and we will write, and we will simply run the program, and we will see. And you can also x label, put x label and y label here, control C, and we will put control V, and we will simply remove this. I forgot the key, shortcut key to remove this. So now let's see what it's coming. So something went wrong, so we have to like plot this. We have to use I forgot we have to do replot here too, so we can do replot, and we have to write 0 comma 0 comma 20 comma 30, and simply, and we have come. I suppose this much will be enough for this graph to come. No, it's still not coming, so something went wrong here. So let's see what is it. So let's first write the value of p. So p's value is coming out to be correct. Now r's value is coming out to be correct, and now w's value is coming out to be correct. So now we have pw, pr, and w. We have -1, -4, and -4 lambda in micrometers. So let's see what we have written done wrong here. We have done everything right. L into 10 to the power minus 10 to the power 6. So I suppose what I have done wrong is I should have simply multiplied this L by 10 to the power minus 6. I don't know the correct reason for it. I forgot it. But I suppose we are converting the lambda L in micrometers to like for scaling it, I suppose. Now let's see what's coming. So now it's coming out correct, and if you cannot see it because of the symbol, but if you can see clearly that there are, I can write legends here. So you can simply like we can form a name matrix NME. So we have to take into account this into L into 10 to the power 6. So we can simply remove this 6 also and have the form. So now I also learned something. You can remove this also because you have to scale down it. So scale down a little, I suppose. Yeah, I suppose, है ना. Whereas that for that it was coming out to for like it was not scaling out to be correct. We have to lint space. We can use it on lint space. मतलब replot too. We can simply, I suppose, if we don't want to do this, we can simply do this. We are already taking them into micrometers, so why do like this? So no, I suppose I did something wrong, so let it remain like this. So now you can simply get the idea. You can use the legends and get the name of these plots. This is the Planck's edition, sorry, religions law. This is the upper one is the Planck's, and the lower one is the religions. So now you understood the second code, and now let's go to the third one. The third one is little more complicated than the last one. Now the third one has the clear CLC CLF. Again we have to write clear CLC CLF, and let's save it with the name video of code number 3. Video code number 3. So now this code, in this code uh, we have to simply see the various type of various laws that were given by we can say that were given by Planck's, sorry, that were given by Debye, Dulong Petit, and Einstein, sir. So generally the law of the Einstein's law fail at lower ones, and both law fails at lower temperature ranges, because at lower temperature ranges there is tube dependence, and they could not explain tube dependence. So first we have to these are simply very simple formula. So we have to show for lower temperature and higher temperature there are two formulas. I will draw down the formulas here, so you can learn them simply. Now we can The first formula we have is 3 NAK. This is for Dulong Petit. And now for now for Einstein gave that 3 NAK T का होल स्क्वायर e की पावर T upon T डिवाइडेड बाय e की पावर T का हो -1 e की पावर T upon T -1 का whole square. This is the formula given by Einstein. Now, the formula given by for low temperature ranges first. So for low temperature ranges, it is for by Dulong pattern. So by d by it is 12 pi की power 4 upon 5 NAK into T upon TD to the power Q. So from here it comes that T cube dependence of at lower temperature, and for higher temperature we have the formula 9 NAK T upon TD ka whole cube. And now we have integration, just reverse this TD upon T, and now from 0 to TD upon T, and now here write y to the power 4 e to the power y upon e to the power y minus 1 ka whole square dy. So this is for higher temperature ranges, this is for lower temperature ranges, this is for higher and this is for lower temperature ranges. So the temperature ranges that we will be taking are simply 0. Is 1 to 100, I suppose. Let's see first what I have taken. Is 0.0001 to 100. I was correct. 0.012 to 1 to 100. This is the for low temperature ranges, and for high temperature ranges I suppose I have taken 1, say 1 and 700, I suppose. Let's see, 0.1 to 700, I suppose. 1 to 1 and 700, so these are correct. So let's see how to plot do this. So simply start by giving the values of kh, and simply again like 1.38 into 10 to the power minus 23. Give the name of Na as Avogadro's number, capital N and A. Sorry. Yeah, write this down as caps lock Na 6.022 into 10 to the power 23. Now we have these tools, and now we can simply have TD and TD. I will you can make the from the code like very complicated, or a little bit it's not complicated, a little bit more systematic, by giving the input of taking the input of the name of the solid by using solid name is equal to input solid name or anything. A is equal to input, enter the name of the solid and use the string and comma string for using taking input in the form of strings, and then for further do it and then take the temperature TD and TDT. So I will directly take the temperatures TD and T here. So TD for copper is 343 and Kelvin, and T for copper is 240 Kelvin. I don't remember for diamonds, so these are the ones I will be working with. So now we simply have to have the temperature ranges. So first we will have for low temperature ranges, so 0.1. So we will start from 0.1 with step size of 0.1 and go up to 100. So let's make I like condition. So display, we can write enter 1 for this. I do in my codes a lot because I like this, but for simplicity I will not do it. First I will show for lower and then I will show for higher, and if you are memorized you can simply put them into conditions if and else. So if any quantity is 1, like suppose k is 1, then put no, like a is 1, then put a code inside it for low temperature ranges, and for anything that is that temperature is less than 1, the input is another other than 1, then put the code beside behind it for high temperature ranges. Simply a condition, it's like a condition. So now let's do for simple for low temperature ranges. So we have a low temperature range. Now we can simply take the length of T, length of T as LT. So we will don't have anything to worry about. I do this a lot. LT is equal to length of T. So now we will use a for loop for I is equal to 1 to LT. So now we have a for loop, and now we can put the three formula. Again I will use the formula from not this code. I will use the formula from my this code because I already made it and I will be showing you. This is for the low temperature entity, so simply copy it, control C. I have simply written the formula here, है ना? So I have to fill see the brackets also, so it might come wrong. So this is, let's comment it out. So DPCV means Dulong Patil specific heat, ECV means Einstein specific heat, and DCV means device specific heat. So you can see the formulas. T upon T is simply the formulas are same. T upon T exponential T upon T exponential T upon T minus 1 whole square. 12 pi power 4 NA K Ti upon TD into 3 into 0.5. 0.5 is simply 1 upon 1 upon 5. 2 upon 10, 1 upon 5. You can simply write like this, 1 divided by 5 and come bracket like this, है ना? So this is a where this is like, let's see if we have all eyes only temperature I, temperature I, temperature and no other values. So simply we can now plot 2D, and now we have on x-axis we have temperature T, comma we can now we have to now plot first DPCV, comma DCV, comma and ECV. Now it will plot them all together, and now we can simply F5 and we have a syntax error. Wow. So it is saying that the syntax error unexpected identifier I'm expecting another line T. So LT is not specified, so we can directly remove it and simply write here a length, LENGTH. I suppose I wrote the spelling of length wrong. So now we have this wrong input arguments, plot 3D. Sorry, for plot 3D I put plot 3D, plot 2D. Now we will have the graph. So this is the graph and it is coming out to be correct. And now we can simply for high temperature in this put this as 1. You can let it this only, but there will be many there will be many points, so let's too many points for a computer to handle in computer may crash too, so don't try to give it too many calculations. So let's simply change this formula. I will show you, only have to change this formula. So I will again, sorry, my telegram opened, I have to quickly close it. So hope that you don't see anything. So anything, now let's see this power saving and more saving power. So I don't study a lot, but I will show you how to do it. So now the formula of integration, this is the formula I suppose. DCIV is equal to integrate this. I will simply control C it and control V it, and I call this not cheating, I call this sharpness of mind. If you have any problem, then you can so control Z it, and let's see if it is coming to the same formula that I have told you. Let's see. DCIV, let's simply take one, integrate y to the power 4. So now we have to learn about this integrate command too. We have to write integrate, and we have to, I don't understand this integrate command. Achha, so sorry. We have to write the function into the first one. So we have to write function and we have to write the variable and then we have to write the limit. So we have to write the function y to the power 4 exponential y minus 1 whole square, and we have to write y 0 and td upon te, td upon ti, or then this bracket and into 9 into nak into ti upon td to the power 4. So this is our formula. So now we will have the, simply we will run the code and we will again have the graph. No graph. So this is the graph and it is coming out to be correct. As you can see, this one is for Einstein, this is for Dulong Petting. Einstein curve cuts the Dulong Pettit curve like this, and it's for Dulong Pettit simply. Now this code is finished, so we have to understand this part of the code. So we can again control C and write it here so that we don't remember, we don't forget it, and we can control D it, control D it. So integration, this is for writing the function है ना. So what function is to be get integrated, that is y to the power 4 e to the power y upon e to the power y minus 1 का whole square. And what is the variable here? Y is the variable from where to where the integration is going 0 to td to minus ti. We have to write this in commas, and td upon ti is the limit, next one limit, and this is the brackets here, and 9 nak is the constant, and ti upon td to the power 3 is outside the integration, I suppose. So you can simply write this also, which we can do this control V, and sorry, what I did, control Z. I was like doing like I was like showing to you that control, you can control C it, and you can place it in the front of the integration, control V it, and simply multiply it using this, and or you can simply put the integration in the brackets also. This formula works too. You can see control, we can control C it, control C, and uh, you can control D this line, and you can simply control V it. So now you can write DCVI. So now you can also see still the graph would be come out to be same. Let's see the graph. No graph. Yeah. So you can see the graphs coming out to be same. So we have done three codes. Now let me take a break and I will come right back at you. So the life has been hard, very hard for a few days. My roommate and his friends and everybody is like doing so much hampering in my stuff or hampering in my stuff so that I can't even understand it. And my message for Aman is that I'm trying my best to be strong, and for Nishikata bro is that I'm trying my best, and for Aman is that I feel very far away from you, and it may sound cliche, but what it is. Though my English is not very good, but I'm trying to say in English so that other people, if they listen to it, they don't feel anything or they don't know what I have been doing or anything else. Also, Nishikata bro, I'm a big One Piece fan now. Tomorrow is my test, and still I was trying to find the manga for One Piece. So if anybody of you complete this video, complete to the video to the end, and you know a good manga place like Juru Tutu is a very good anime place like to watch anime. So and I don't know what to say. I will say there are too many variables in life. So and also I didn't give I did get jam exam and still I regret it. I didn't give many exam at all. I didn't try it too much at all. So you should try it and give me some food when I am going on a bicycle alone by myself to Japan. I will go there, I suppose. So let's end it. So goodbye.